Hi, I'm Adam, the creator of SUMO,
Hello, I'm Jenny, a student of SUMO.
and we're here for another podcast. Today we're going to do a little introduction to how to do some basic coding in SUMO of what we might call action sentences. And so we're going to start with an example I use throughout my book that's actually taken from an author named Terence Parsons, who has a whole book on how to use logic to code the semantics of English sentences. It starts off as, I think, a really good and useful example. So,
And you call that case roles in SUMO term or just normal?
yeah, case roles. Case roles, this is a phrase from formal linguistics. It just refers to the roles that things play in sentences, in actions.
Right.
And it's often, I guess it's called case roles because it's often referred to what linguists would call case or gender, these sort of linguistic constructions. But that's not really our topic today, isn't so much linguistics as SUMO.
Right. And it's about processes, aren't we?
Yeah, we're talking about SUMO processes. So hopefully, if you're watching this, you will have looked at some of the previous podcasts we've done on how to write a basic term in SUMO and maybe how to use Sigma, because we're going to be using Sigma during this podcast as well.
Right.
So here's Sigma, or here's the SUMO homepage. So we'll go to Browse, and we'll just, let's bring up Process for now. Okay, so this is the sort of main class having to do with actions. And we should also take a look at case role. All right, we'll just leave this up in the background. I'm not going to go into it yet because we've got to get a little preliminary information straight about
Okay.
what case roles really are.
Let's talk about something though. Maybe we could go
Okay, you want to go
deeper,
through
like predicates, like agent, patient.
Okay, well, we'll talk about it a little here, and then I'll go back to the
Sure.
slides and we'll see. All right, so case roles, so the informal English comment, again, the comment, the documentation string is not the definition of case role. The definition of case role are the formal mathematical axioms.
In SUMO.
In SUMO, yes. So here it says the class of predicates relating the spatially distinguished parts of a process. All right, so if you think of an action happening in the real world, there's somebody doing the action, maybe he's doing the action to something else, the direct object in a sentence, maybe he's using an instrument or a tool. These are these spatially distinguished parts of a process that are all part of an action going on.
Okay.
And here it says, case roles include, for example, agent, patient, destination, and action. So, I'm walking somewhere, it has a destination.
Right.
That's part of the process.
And
Yeah.
you are the agent.
If I'm the agent, I'm the agent. If I'm walking somewhere, I'm the agent of a walking process.
Right.
So here it says also the flammable substance in a burning process, right? So if I've got a fire is a process. It's burning the wood is participating in this action. If it's raining, the water that falls in rain is the patient of the rain. It's the thing that's sort of the main focus. Anyway, so maybe we'll go back to the slides and start through this little example from Terence Parsons.
Yes.
It's a little violent from Roman history of Brutus stabbing the Emperor Caesar.
Right.
So Brutus stabbed Caesar with a knife on Tuesday. So there have been many ways over the years that linguists have thought to represent this stuff. But here's a sketch of how we do it in SUMO, how Terence Parsons, who came up with this example, does
Right.
it. And ultimately, this is all thanks to a guy named Donald Davidson in the late 60s who came up with this. He was a linguistic philosopher.
Right.
Very important work. He had a paper, The Logical Form of Action Sentences.
Okay.
I recommend that. So,
Should I try to
yeah, go
call
ahead.
them? Say, in this case, stabbing is the process.
Right,
And then, well, Brutus is the agent.
right,
And the one that being stabbed is Caesar. So Caesar is the patient.
right.
And then he used a knife. The knife, I would think, is an instrument, isn't it?
Yeah.
But what about the time?
Yeah, this is the time at which the action happened. It happened during a Tuesday.
Right.
It happened on Tuesday. So let's go to the next slide where we can show all these relations, right? So Caesar, as Jenny's just said, is the patient, Brutus is the agent, the knife is the instrument, and the time is Tuesday. Okay? So the nice thing about this is that once we've defined an instance of a stabbing, right, a particular individual stabbing, then we can relate a whole bunch of things to this stabbing. And that was the key
Right.
advance that Donald Davidson came up with intellectually about how to talk about actions in the world and how to talk about it in a way that's amenable to coding in logic.
There exists a stabbing.
Exactly. There exists a stabbing. So that's how you'd phrase in English what the logical expression would be. And so let's take a look at that logical expression. So here we go. All right. So in SUO-KIF format using SUMO terms, there exists a stabbing, a knife, and a Tuesday, where the agent is Brutus, the patient is Caesar, the time at which the stabbing happened is the instance of Tuesday, and the instrument used in the stabbing is an instance of a knife.
Right.
Okay, so this really says all of it. So the key things to pay attention to is like we have to have an instance of a stabbing, a particular stabbing, right? Not stabbing with this capital S is the class of all possible stabbings.
Right.
Knife is the class of all possible knives.
Right.
And here we're saying, well, there exists one of each of these things. We haven't named them. You know, we could have named them. We could have called it, you know, Brutus's knife is an instance of knife, but we can just as easily say there exists some variable K
Right.
that stands for this instance of a particular knife.
Right. So to be more precise, there's somebody called Brutus stabbed somebody called Caesar. It may not be the same Brutus or the same Caesars we understood.
Yeah. So specificity is important in this little example. We haven't talked about, you know, how do we know which Brutus it is. Jenny, in some of the exercises you're doing now from the SUMO book, you're using the term, the relationship names, so that you define Brutus and you give him a little string that is the name Brutus, Brutus, etc. That helps a little bit. You know, we could talk about we could specify where Brutus was born, what his social security number is in modern terms, all these things to identify individuals uniquely in the real world. That's maybe a little bit beyond our scope today, though. Maybe the hardest thing in this is the temporal qualification, because I know that's been some of a challenge for you.
Yeah.
So here, talking about Tuesday, right? So Tuesday is the class of all Tuesdays that have ever happened in the past and will ever happen in the future.
Right.
That can be a kind of a tough concept to get your head around. And here we're talking about an instance of a Tuesday. We haven't said which particular Tuesday it is. We just said that there is some Tuesday. It definitely happened on a Tuesday. We don't know what year, what month, etc. But we know it happened on a Tuesday. So we're talking about an instance of a Tuesday during which this action happened. Okay. So that's really all there is. If you use this form as a model, then you start to quickly to get the hang of how to represent any kind of action in SUMO. And I think in future, maybe longer podcasts, we'll go into some more complexities. But if you can get this part down and do a couple of examples, then you're well on your way to being able to talk about action sentences using SUMO.
Yeah, but I would also recommend actually for students to actually browse in Sigma to look up on terms like what an agent is, an instrument, and what a process. Spend a bit of time on the web page.
Yeah, definitely. So that points out a little more that we could go over. So here we're back in Sigma, and you see there's lots and lots of different case roles. In fact, there's a whole hierarchy of case roles. If you look at, there's a little diagram in my book, the Ontology, a practical guidebook, that shows what all these are. But there are a few that you're going to be using a lot. So there's agent. Destination is very common. Changes location is not so common. Experiencer is quite common. Origin is also common. Path. Patient is nearly universal. In fact, there are also a lot of subclasses of patient. Object transferred is something that we should use more of. It's something I actually defined fairly recently in one of these domain
Okay.
ontologies in cars.kif.
Right.
Okay. So, poke around in Sigma as much as you can. So not only case roles, of course, but also process. If we take a look at process, there's lots of subclasses of process, and getting familiar with all of the processes and subclasses of processes in SUMO is very important. You'll see a lot of use of various kinds of communication. Dual object process is a lot of useful stuff, attaching, detaching, separating, a lot of intentional processes, things having to do with thinking, planning, learning,
Right.
games.
This is very neat. How did you get here? From the previous web page. I think
Yeah.
it's very useful.
So let's go back. So if we have any class in
Right.
SUMO that we're looking at, we can go to the upper right here to the graph link.
That's very useful.
Yeah, and graph has a lot of nifty controls on it. The first thing is that any transitive binary relation
Right.
in SUMO forms a hierarchy. We talked about this a little bit in one of the previous podcasts. So
Right.
not only can you use subclass, but you could use part and
Right.
subattribute or subplan. There are all sorts of these relations. But it is true that typically the one that you're going to pay the most attention to is subclass, because that's your
Right.
taxonomy. That's kind of the backbone of SUMO.
Okay.
And then you've got all these controls. You can see how many direct children each of these terms has. So if I expand
Right.
intentional process, it's going to have 29 subclasses ultimately in its subtree. You get a little hint of the definition over here.
Right.
If I click over on the graph link, then it starts with intentional process, one above, one below,
Right.
and gives me a lot of detail. And as you see, there are a lot of these intentional processes.
Very useful.
Yeah, and you've got a choice of selecting some columns, customize it a little bit. You can get more levels above and below. You can limit the number of terms, which is important. If you get a big explosion, you want to get as many levels below, but you don't want it to go off into infinity, giving you
Yeah.
all of SUMO. That's important.
Maybe we could spend some other time in the future looking at this, because I think in order to get used to the code or terms in SUMO, we need to have some sort of very handy, easy visual tool for us to go back and find out what exists, what doesn't exist, what need to be defined, what need not to be defined.
Yeah, that's a good point. So there's, especially early on, the sort of tools in Sigma that you're going to use are going to be a little different than the tools that you use once you get at a kind of expert level. I don't use the graph display very often because I'm so familiar with it. When you're just learning SUMO, getting the graph view will
Yes.
be very, very valuable. So definitely, let's do a future podcast on graphs.
Yep, I
Um,
think so. It's going to
but-
be very useful.
But unless you have any other questions, then I think we'll wrap up this one on case roles and action sentences. Hope it's been helpful. Eager to have feedback from anybody that's listening to this, and we'll talk to you later.
Bye.
Bye.